What's going on, AWS Twitch? It is Wednesday. It is 1:11. I am late. I apologize for that. Completely lost track of time. But you know what we do every week at this time? We do streaming on. Welcome to Streaming on Streaming, Wednesday, March 22nd, live from San Francisco. Once again, Streaming on Streaming. I am Todd Sharp, the Principal Developer Advocate for Amazon Interactive Video Service. Million apologies for the late start. The time zone switch has got me all messed up, completely missed out on my schedule, calendar reminder, but better late than never. I am here in San Francisco. I am at Twitch headquarters today, hiding in one of our little booths here in the office. And I am in town for GDC, the Game Developer Conference. And I got here Monday night and have been going pretty much nonstop since I got here. Let's see here. Anybody in chat yet? Moobot, RJRG. 1989. Welcome, everybody else. Welcome to the show. I feel like I don't have time to breathe this week, but that is, I say that 100% in a good way. It's been a busy week meeting with developers and attending some sessions, some meetings, all of that good stuff at GDC. I attended the San Francisco Game Dev Meetup after party event last night at DNA Lounge, and let me tell you, it was an amazing event. From what I understand, 2,000 people attended the event throughout the night. We had a little room up in the second floor over in the corner where many of us from various companies did some technical presentations, which you think sounds kind of crazy at a party with 2,000 people with like full-on laser show and music and all of that good stuff. But I tell you what, it was amazing. It worked out really well. They had a little stage there, kind of, like I said, off in this separate room, so you couldn't quite hear the music, but they had a stage, a projector, a little podium, and a microphone. And I did a talk that I'm actually going to dive into more about here in the live stream, and that is live streaming web-based, browser-based games to an IVS channel. When people think about live streaming, and hello, Lazy Coder 3, welcome, appreciate you joining. And anybody else, feel free to give a shout out in the chat and let me know where you're at, what you're up to, what you're working on, all of that fun stuff. So yeah, streaming browser-based games. We have talked in the past here on Streaming on the live stream about the Amazon IVS Web Broadcast SDK. So as I started to say earlier, gaming and live streaming are pretty much interlocked in a lot of people's minds. When you think about Twitch, when you think about live streaming, you think about Twitch, most people do. And when you think about Twitch, you think about gaming. And for a lot of gamers, a lot of content creators, this means that either they're playing a game on their PC or on their console. And if they're on their console, they may be using a capture card to go to a PC, running it through something like OBS, Streamlabs, some of the other software on the desktop, and then producing that stream to a Twitch channel. And most of the time they're adding maybe their webcam over top of that stream, or they're producing it directly from the console. There's a lot of consoles that have support for live streaming directly from the console itself. So like Xbox, I know as an Xbox gamer, I know you can set up a Twitch stream and stream directly to Twitch from the Xbox. And this works. there's nothing wrong with this workflow. It's a good way to get a live stream of a game out on the internet and interact with chat viewers and produce that type of content. But if you think about what that means that your stream is going to a third-party application, in this case, Twitch. And again, there's nothing wrong with that. But for some game developers, it may be interesting, it may be advantageous to maybe create their own platform. Maybe they want to create a application that allows them to integrate the streaming experience into the game itself. This gives them the ability to brand the player, customize the experience, maybe include game statistics into their live streaming viewing experience, maybe include interactivity into their experience. So it opens up tons of possibilities, and I think is a really exciting potential use case for interactive video service. So what I wanted to do today is kind of walk you through how you might do that, how you might integrate live streaming into a browser-based game. So we're going to look at a couple open source games, and we're going to stream them directly to an Amazon IVS channel via the Web Broadcast SDK. So if you think about the Web Broadcast SDK, obviously it involves JavaScript, right? Because it's a Web Broadcast SDK, but it creates, it produces a WebRTC stream, live stream, and that live stream is ingested into our WebRTC servers, converted to RTMP, which is the traditional protocol when using something like OBS or something other desktop publishing software. And then that RTMP is then converted to HLS, which is delivered to the browser. Pretty standard workflow, but the Web Broadcast SDK gives you the ability to add video input sources to a live stream publishing to an IBS channel, right? And when you add those video input sources, you have multiple options. You could use a webcam, obviously a common use case if you want to stream your face as I'm streaming right now. You can also add a pre-recorded video if you wanted to. I have some blog posts about that for maybe like reaction style live streams or injecting intro videos like I do here on the live stream, or whatever you need to do. You could add pre-recorded video. You can also add screen share. So if you use the get display media method of the JavaScript API, you can get a media stream from your browser or your desktop that you want to screen share, and that can be used as a media stream source for your video input. However, another way to do this, another way to get a media stream is to get a media stream from a Canvas element. And most browser-based games, unless we're going back into the past and using Flash, which I don't think we're doing because it no longer exists, but most browser-based games use Canvas to render the game. So because you can get a media stream from a Canvas element, it provides a really ideal source for a media stream for the Web Broadcast SDK. And it's really easy to do. And we're going to walk through that process of adding it to an existing game here on the live stream. So I think we should jump into that, and I will go ahead and share my screen. And there we go. All right. So I'm going to hide my StreamYard so that we don't get a little echo effect here. And we're going to hop into this game called Pac-Man Canvas. So I found this game on GitHub. It is an open source version of the what year did Pac-Man come out? 1980 something, maybe 70 something. It's an old game. I think we're all familiar with Pac-Man. If you're not familiar with Pac-Man, let me know in the comments because I'd like to know how you've never heard of Pac-Man. It's pretty ubiquitous. It's a pretty well-known game. But this person, Platts Hirsch, and their website is plattshirsch.ch, created this version of Pac-Man that uses Canvas and runs in the browser. So I cloned the repo from GitHub. I opened it up, and the first thing I did was open up index.htm, and I searched for a canvas. So I found a canvas with an ID of my canvas, and I thought, excellent. This is the gameplay canvas that is used to render the game. And if I come to the pull it open in my browser. For now, let's ignore the broadcast button. But as you see here, and let me know in the comments if you cannot see my screen here. Actually, let me make sure that y'all are seeing that. I can find my window. Where did I do with that window? There it is. Okay, just quickly peeking. All right, excellent. Looks like you can all see that. So I will minimize that. Perfect. So here's Canvas, Pac-Man Canvas. If I click it, I can play the game. I can move Pac-Man around with my arrow keys, eat the little dot pills, whatever they're called, and play the game. Everything renders in the canvas. Everything looks good. And what I want to do now is live stream this game. So take note, up here on the top, we have the score, we have the level, and we have Pac-Man's lives, remaining lives. In this case, I just lost one, so it's down to 2. But if we inspect this element, we can see that that is just a plain old div. These using a fancy font, little video game type 8-bit font, but the score is outside of the canvas. So the canvas is actually not part of, the score is actually not part of the canvas. So the canvas container is separate, it's down here. So keep that in mind. The only thing that we're going to stream is the gameplay field itself. So the square within the canvas. So if we come back to the code and we open up pacman.js and we scroll down a little bit, we can see a function that basically handles all of the initialization. Where is it at? Let's do a find. Okay, so this uses jQuery, and I didn't modify any of the game code. I just kind of took it as is and decided to add streaming to this game. So it uses a document ready function, and this is where all of the initialization of the game happens. It does some setup, it renders the game board, it attaches a keyboard listener, all of that good stuff that needs to be done for the game. And if I scroll way down to the bottom, right after the render content function, I added a call to this init broadcast client function. And in this function is where we're going to initialize a broadcast client using the web broadcast SDK. I should also note that over here on the HTML file, I did include a link to the web broadcast SDK in a script tag. And that is, other than adding the button, that's the only modification I made to the HTML file. So within init broadcast, The first thing we're going to do is grab a reference to the game canvas. So using get element by ID, we'll grab a reference to that game canvas. And then I need to get my configuration. So my stream key, my ingest endpoint, I've got a Lambda function that returns those elements. So we're going to make a call to that. I have a variable set up containing the URL to my Lambda function. So that is called config URL. So we'll make a fetch call to get the configuration, and then we'll set a global variable for config to the result of config request.json. So we're going to get a JSON object back containing my configuration for my live stream. Obviously, we never want to store stream keys or anything sensitive like that in the source code of the application. And also, I mean, if you're talking about an application that has multiple streamers, each streamer would have a different stream key. So you want to get that from a backend, store that in a database, or wherever you need to make sure that it's not in the source code and it is dynamic for each user. So we're going to now initialize a instance of the broadcast client, and we do that with IBS broadcast client.create. We pass that an object, and within that object, we need a stream config property, and the stream config property will use a value from the enum in the standard broadcast client, and this is just a object that contains things like your width, your height, all of that important stuff. And instead of passing it manually, we just have some predefined variables that you can use for a standard channel in landscape mode. In addition to that, we need to tell it the ingest endpoint. And the ingest endpoint in this case is coming from my config property. And I don't think endpoint is proper. I think it's endpoint. There we go. So we have a broadcast client created. Now we can add the video input device. So we say add video input device. And as I said, this expects a media stream element. And we can get a media stream element from the canvas by saying game, which is the DOM element that represents our canvas, game.capture stream. We need to give it a unique name, so we'll call it game track. And then we also need to pass a configuration object. In this case, the only thing that's required is the index, and you can think of this like the z-index, kind of. Essentially, it's the layer at which this video input device, this media stream, is going to be broadcast in your stream. So if you want to do composite a webcam on top of it, you could possibly do that using grabbing a reference to the media stream or the input, the camera, your web camera. And you could add that at index 1, pass it the X and Y position on the canvas and the height and width. And that can allow you to, let's say, position it in the bottom right corner if you wanted to do that. In this case, we're just going to do the game and publish that as our channel, as our stream. What else do we need to do? Well, we can use the on method to listen for connection change events. So if I say broadcast client events dot connection state change, we can listen for that event. So every time the connection state changes, whether we're connecting, whether we're connected, whether we're closed, all of those various state change events will be handled by this handler. That receives one argument in the callback, and that is a string representing the state. And we can set a global variable, in this case, to the result of whether the broadcast client state equals connection state dot connected. So this global Boolean variable is basically going to be true if the connection state is connected. Otherwise, it's going to be false. What else can we do here? We can get a reference to the button. Let's do get element by ID. We'll get a reference to broadcast button. My notes over here. And we can say button.innerHTML equals is broadcasting. If it is broadcasting, we can change the button label to be stop broadcast. Otherwise, we're offline. We can change it to say broadcast. Okay. Now, actually, let's see here. Let's also enable the button. So we don't want to enable the button until our broadcast client is ready. So initially I have it disabled. We can remove the disabled attribute because the broadcast client is ready to go here. And we can also add an event listener or click events. And in that event listener, we'll call the toggle broadcast method. So every time the button's clicked, we want to call this toggle broadcast method because we have a broadcast client ready to go. And within the broadcast client, or the toggle broadcast method, we can check whether or not we're broadcasting. So if not broadcasting, we can call the start broadcast method, passing it the stream key. Otherwise, we'll stop the broadcast with stop broadcast. We can also add a class to change the look of the button if we're online, and remove that class if we're not broadcasting. All right, so those 30 lines of code that I added to this game are basically all that I need to add to this game in order to get it live streaming. So if we refresh the page, and okay, we've got a little error. So let's see here. Check my notes. I may have misspelled something. I think it's broadcast client events. Yes, broadcast client events. So let's refresh that. All right, excellent. Our broadcast client is configured. We've attached a listener to this button on the page. And when that button is clicked, since we're offline, is broadcasting is false, it will start to broadcast this game. If we are online, conversely, it will stop the broadcast. So if I click to play and I click the broadcast button, you can see the button turned red, the text turned to stop broadcast, indicating that we are broadcasting this live stream. So if I move this down a bit and I pull up this viewer on the right-hand side, this is a viewer that I have set up that is playing this live stream. So if I zoom in a little bit to avoid confusion, and I start moving Pac-Man around, you can see on the right-hand side, got about 2 seconds worth of latency, which is not bad considering I'm on a Wi-Fi connection, not hardwired. But yeah, we got 1080p. We are broadcasting this game to an Amazon IBS channel in about 15 minutes of work, 30 lines of code, 15 minutes of work mostly because I talked you through the process. Honestly, in all reality, it would have taken me about 5-10 minutes tops to get this browser-based game in a canvas broadcasting to an IBS channel. Now, as I said, we don't have the score element, we don't have the level, and we don't have the lives rendered over here on the player side of things because they were not inside the canvas. So what can we do to kind of customize that experience, make it something that is really engaging and entertaining for our viewers, and just really kind of take it to the next level? Well, we can inject those elements as timed metadata in our live stream. So timed metadata, I've talked about it before, but if you're not familiar, is a piece of data that can be injected at a specific point in time in an Amazon IVS live stream. And it's useful for doing things like trivia games or product placements or coupons. If you're talking about a live shopping experience, it's just a nice way to associate a piece of data with a point in time in a live stream. And the really cool thing about timed metadata is it is actually embedded in the stream itself. So it's an artifact of the stream. So if you were talking about maybe saving your videos to S3, playing them back on demand, that timed metadata still exists. It's a tag that you can listen for on the player side and take any action that you need to take based on that time metadata. And it can be any data that you need it to be, as long as it's smaller than 1 kilobyte, which sounds like a low limit, but in reality, you could, if you needed to, create pointers to pass an ID instead of an entire object of data, save something on the broadcast side to a database, or retrieve an ID from a database, for example. Pass the ID as the time metadata, not the object itself. And on the viewer side, you can make another call to the database or to a key value store or some kind of cache and pull that data back. So 1 kilobit sounds like a small limitation, but it's not. So I have this publish metadata function. And in order to publish metadata, timed metadata, we can use the AWS SDK for whatever language that we're comfortable with. I'm using JavaScript, in this case, Node.js, in a Lambda function. You could use Java, you could use Rust, Go, any of the supported languages in the that are supported with the AWS SDK. You could use those to publish your metadata. So I have this publish metadata function. It makes a fetch call to a URL, and it posts any metadata in string form, posts any metadata to that channel. Now, I wanted to use this to update the score, the level, and the lives in my viewer. So what I did was I came down here to the score function of the Pac-Man game, and in the add method, when the game is incrementing the score, I check whether or not the channel is broadcasting, and if it is, I publish metadata containing the score, the level, and the lives from the Pac-Man game into that stream. So what this looks like, we come back over to the game and we scroll down a little bit, zoom out, is if you watch the right-hand side as I'm playing, you should notice that the score gets updated in the metadata renderer down here on the bottom of the live stream. So if I start to play a little bit, you can see the time metadata events coming in and the score, level, and lives being updated in the renderer over here. So I could use this to render an overlay onto the game. I could do it outside of the viewer, anything I needed to do to update that score, level, and lives. And this opens up so many possibilities. I think it just really gives developers the ability to create these custom live streaming experiences. Maybe I could create a chart that charts my score over time. Maybe I could use the XY coordinates of my character and render them on a mini map outside of the viewer in the viewing experience. There's so many things that could be done with this timed metadata that really enhance the live streaming experience when broadcasting a game via the web broadcast SDK. So In 20 minutes or so, we have taken a look at how to live stream a Canvas-based game using the Web Broadcast SDK. I think it's pretty cool. I think it's pretty powerful. How can we take it a step further? How can we make it a little bit cooler and add some true interactivity to this experience? In fact, let me jump back over to StreamYard and make sure that there aren't any chat questions that have come in up to this point. So if I come back to StreamYard, apologize for the little echo effect there. Cool. All right, so no questions have come in. Excellent. If you do have any questions up to this point, please let me know. If you're just joining us, we're talking about live streaming web-based games using the Amazon IVS Web Broadcast SDK. And we just took a look at adding the Web Broadcast SDK to an open source game and live streaming that game directly to an IVS channel. How many of you are familiar with Twitch Plays Pokemon? It was this kind of, Kamba says, is there any way to watch this series on demand? Yes, Kamba, there is actually. So I'll post a link in chat here. All of these episodes are available right here on the AWS Twitch channel after the fact as videos on demand. But I also publish them to my YouTube channel, and that's youtube.com/c/recursive codes. So if you want to check that out, there's a playlist for streaming on streaming. If you want to subscribe to that, that would be awesome. But yeah, publish all of these usually within a few days, if not the next week. I definitely publish them all to my YouTube channel so you could watch them. Sometimes I also try to kind of distill them down into like smaller clips that just kind of focus on the really technical details of the episode, but I don't always have the time or ability to do that. But I call those stream drops. So if you want to check out that playlist as well, you can hopefully learn some more about IVS over there. So Twitch Plays Pokemon was this experiment that someone set up quite a long time ago. And essentially they're live streaming Pokemon. I can't remember which Pokemon game, but they set it up in such a way that the actual gameplay itself is controlled by chat viewers. So people can come into the chat on Twitch and they can basically play the game. They can tell the character to move, tell it to perform some action. And it's just this really crazy thing that's been running for like a long time, years at this point, I believe. And it's just wildly popular. So I thought, how could we kind of create this kind of experience with Amazon IVS and the Web Broadcast SDK? So what I did was, I'm going to share my screen again and minimize this. So what I did for this was I downloaded another game called S2E11. And what S2E11 is a game, it's a maze-based game, a 3D WebGL-based maze game, where essentially you take a ball and you move it around a playing field and control the action in the game with your keyboard. So if I open this up here, another tab, give you an idea of how to play. So it's just, like I said, this 3D based maze game where I can use my keyboard here and control the movement of the ball throughout this maze. And pretty neat game. But I thought, why don't we set this up to allow chat users to control the movements of the game? So I went through the broadcast side of this game, and I essentially set it up the same way that I set up Pac-Man. I get my stream configuration, I create an instance of the broadcast client, passing it the stream configuration, my ingest endpoint. I add a video input device, in this case, the canvas element for the game again. Gave that a unique name, pass it a configuration object. And then I also have another broadcast button that does the same thing that we did just before. We call start broadcast. If we're not broadcasting, we call stop broadcast. If we are broadcasting, I basically toggle the stream with this button click. To add the interactivity, I also added IVS chat to the gameplay. So if you see here on the right-hand side, I've got this chat container that renders all the incoming messages. I've got some game instructions here that tells users how to play the game. And when I'm broadcasting, when users are connected up and viewing the game, which I've got this viewer over here, they can control the gameplay. So if I start this broadcast, and I refresh the page over here, we can see the live stream of the gameplay up on top. In this case, it's on top because I've I've changed the size of my window. But in your case, you'd probably see it on the left and the right. So if you want to play along with the game here, you can go to, in fact, let me post that in the chat. So apologies again for the echo effect. I'll remove that quickly. So I will post that in chat. And if you want to play along, I'm quite sure that that's the link. Let me double check that. It is not the link. Apologies. The correct link is game player. All right. So posted that to the chat. If you want to play along, go to bit.ly/IVS-game-player. So if you open that up in your browser right now and you connect up to the chat, you should be able to control the gameplay. Kamba is here. Hello, Kamba. So Kamba, if you wanted to control, for example, we could type up. And if you see on the left-hand side, on my broadcast side, the ball has moved up. I think my stream froze up here, so let me refresh that over there. Okay, excellent. So we can type up again, and we can type right. And within a few seconds, as you see on the right-hand side, the ball has moved. And Kamba has started typing commands. We kind of ran into each other with our commands there, but go ahead. If you want to play, you can type those commands. There you go. Kamba's moving the ball and trying to move the ball through the maze. So let's quickly take a look at the code behind that. I will, Kamba's enjoying playing, and we'll check back in on Kamba to see if Kamba actually finishes the maze and gets that ball through the level. So we initialize the chat connection, and within the on message handler of the broadcast side of things, we're basically listening for those commands. So we're going to take a look at the content of the incoming message. If it is one of the acceptable commands, we're calling a move ball function. And in the move ball function, if we jump over to there, we have a direction being accepted. And we essentially are looking into this key codes object for the direction based on whatever the input was, left, up, right, or down. We're creating a new key down event and a key up event as well. The key press event has been deprecated in HTML, so you can't really simulate a key press. Well, you can simulate a key press, but to simulate a key press, essentially what you have to do is dispatch a key down, and then after a set period of time, you dispatch a key up. So in this case, I'm dispatching the key down. 200 milliseconds later, I'm dispatching the key up. So we're just simulating somebody pressing a left, right, up, or down key for 200 milliseconds, and we're considering that a movement. The game itself is already listening for those key codes. So it looks like Kamba has successfully completed the game. Good job, Kamba. You've gotten to level 4. And yeah, so that is a way to create this interactive game experience, letting your users dictate control of the gameplay. Now, what possibilities does this open up? Let me jump back to my StreamYard quickly here and remove that. So what possibilities does this open up? Yeah, nice. Cogdorn says, nice one, Kamba. Absolutely. Completely agree. Well done. Think about a live streaming integrated within a game itself. Think about the possibility of influencing NPC behavior based on polls in a chat. Think about influencing character movement. Think about influencing weather or lighting or textures or environment. There's so many possibilities I think this opens up for gaming when you integrate live streaming directly into the gameplay itself. I think we're just starting to get to the point where we're going to see many more of these interactive experiences. There's companies like Vertex is a company I met with here at GDC. And if you go to, I think it's Vertex Stadium, let me check that. vertexstadium.com. Yes. So vertexstadium.com, posting that to chat. If you check out Vertex, for example, they're creating these interactive experiences for game viewers to view a game live stream. In this case, some of it is involving VR, where you can actually enter into the game environment yourself as a viewer and experience the game, the stream in a whole new manner. You can actually be a part of the game environment. And I think, as I said, we're just starting to see the possibilities of some of these things. And I think as time goes on very quickly here, we're going to continue to see many more things like this happen, many more experiences opening up. And as Kamba says, collaboration while streaming, whole new concepts are coming. Exactly. I think we're just at the beginning of what's possible. So I encourage you to check out the, well, if you haven't checked out Amazon Interactive Video Service, I, of course, encourage you to check that out. New AWS accounts can get 12 months of a free tier. So you have 5 hours of input and 100 hours of output, and I think 13,500 chat messages sent, and something like 270,000 delivered chat messages for free for 12 months. Check it out, sign up, play around. If you don't have a new AWS account, you could still check it out, of course. But yeah, check it out, play around with it, learn about our SDKs, see what's possible. Check out my blog, dev.to/t/Amazon IBS. Posting that to chat. To check out some of my blog posts and see what's possible, see where you can take this, see how you can integrate this into your application, see how you can build your own platform, your own experience with some of these SDKs, using timed metadata, using chat, using some of our native SDKs, the Android SDK, the iOS SDK. Integrate these into your application, see how it works, see how you like it, see what you can do with it. If you have questions, feel free to reach out to me on Twitter at Recursive Codes, or on LinkedIn, or right here on Twitch. Send me a message at Recursive Codes and let me know what you're building. Let me know what you're thinking, what your ideas are, how you'd like to use IBS, what you'd like to see in IBS, how you'd think it could be improved to kind of work with your use case. You know, there's tons of possibilities. I love hearing from developers. I love learning about what you're building, how you're building it, and what games you're working with, what games you're playing with, what games you like to see streamed, all that good stuff. Very much appreciate you joining the stream. Thank you, Kamba. Kamba says, thanks for this wonderful, educational, eye-opening stream. Appreciate you joining, and everybody else for joining. Cogdorn says, thanks, Todd, for this talk. I'll definitely give you a follow and see more of your content. Very much appreciated, Cogdorn. And everybody else, thank you all for joining. Appreciate you being here. And next week, we will be live again. We actually have a special episode next week with a couple special guests from the IVS team to talk about a new feature that's launching very soon. I think it should be launched by the time we go on live next week. Of course, I'm almost positive it'll be launched before we go on next week. But yeah, tune in to learn more about that and meet the guests who will be joining me. And other than that, you have yourself an amazing week. Thank you so much for joining, and I will see you next time right here, twitch.tv/AWS at 1 p.m. Pacific, 4 p.m. Eastern every week. Thanks a lot, and I'll see you next time.